Our task is to write the truth table of the logical statement either P and Q or not Q. Now, there are a lot of ways to read this, but that is just one of the options I chose. Again, the logical statement of either P and Q or not Q. Here we have three different logical operators, but we are going to start with the idea of the logical operator AND for both P and Q prepositions inside the grouping symbol. Then we proceed with the negation of Q before coming up with the disjunction OR for both results. Still, the formula for identifying number of rows for truth table is identified as 2 to the power of n. Even if we have three different versions here, we have P, Q, and not Q, we still have two propositions. That's P and Q. Hence, this is still 2 squared. Again, the not Q is just part or a version of Q, so we only have 2, giving us 4 rows. So we need to construct a truth table with 4 rows, excluding the header. The header will cover P and Q propositions and the rest of the process that will involve later. So we are going to have this as our first column. This will be our second column together with the 4 rows. We have here 1, 2, 3, and then 4. We could also enclose the header into 1 row, but this doesn't count to the 4 rows identified earlier. So let's start by placing the truth value needed for our P and Q propositions. So we'll have here true and true. For our Q, you will have true and false. Then going back to our first column, you have false and false for our P proposition. And you will have here true and false. And as you can see, all different combinations are already identified here. Now, we need to start with the idea of the conjunction, the end under the parenthesis, before going into the negation, or you could also start with the negation, but we are sure that we will have the disjunction last. So let's start with this. You will have the conjunction P and Q. If you were able to memorize the truth table for the conjunction of any prepositions P and Q, you can automatically place it here. But for the purpose of this video, let me try to rediscuss or re-illustrate that. For our conjunction, denoted by this notation here, the result is only true if both propositions are true. That would mean for the first row, true and true, this is true, because that is for the logical operator AND. For our second row, even if this is true, we have false for Q, automatically this is false. Same with the third, this is false, even if this is true, you will have here false. And finally, for our fourth row, both the statements are false, so if you're going to combine them into conjunction AND, obviously the result is still false. This is for the result for P and Q. Before we go to the disjunction, let us negate our Q as the intended pair for the P and Q. So we have here not Q. So looking into this column respectively, the negation reverses the truth value. So this is true, so this should be false. The second row is false, this should be true. The third is true, so this should be false. And finally, we have here false, its reverse is true. Now that we have here the complete results for both, let us now combine them into one logical statement. Is the original one, we have here either P and Q or not Q. Take note that we are now considering these two columns, and the operation now is conjunction. And for conjunction, we only need at least one to be true for the entire statement to be true. Since this is true, regardless of this being false, automatically the result for conjunction is true. Second, false, and this is true, at least one, that's true. Both statements for our third row are false, so this should be false. And finally, for our last, we have here false and true. This should also be true. This is now the truth table for the logical statement I read as either P and Q or not Q. Don't forget to like and share our videos, leave a comment, and reasonably subscribe to our channel.